11.1, permutations and combinations. We are counting today, which just means how many ways are there of doing something, all right? Specifically, when we're talking about permutations and combinations, we're talking about getting a group of items from a group of items. So a group from a group. We might be taking 2 things out of 10 things or something like that. But also what we want to pay attention to is the order in which we take those things. So for permutations, order matters. And for combinations, order doesn't matter. And so a lot of the times on the story problem questions, you really have to focus on whether order matters or order doesn't matter, because one of them is a permutation and one of them is a combination. Permutation, order matters. Combination, order does not matter. So then when they say list all permutations, they're saying 4, 5, 6 taken 2 at a time. Okay, so they're saying 2 of these numbers, like 4 and 5 and 4 and 6. Those are 2 of those numbers. And 5 and 6. And 5 and 4, if order matters, 5 and 4 is different than 4 and 5. Okay? If order didn't matter, then it'd be the same thing and I wouldn't write it down. But since we're talking about permutations and order matters, 5, 4, 6, 4, 6, 5, I see 6 different permutations, 6 different orderings, okay? So then number 2 says 1, 2, and 3. We're just writing them down in order. Well, 1, 2, 3, 1, 3, 2. We're taking all of them, right? And 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. That's all of the different ways of putting those 3 numbers in order. That's what a permutation is. All right. So when it says combinations, order does not matter. So I'm going to start with 4, 5, 4, 6, 4, 7. But I wouldn't say 5, 4. I mean, you can think about it as 5, 4, 5, 6, and 5, 7. But 5, 4, I've already said that because order doesn't matter. That means that 4, 5, and 5, 4 are the same. So if I do 6, 4, 6, 5, and 6, 7, I've already said 6, 4, and I've already said 6, 5. I've already said those, okay? And if I say 7, 4, 7, 5, 7, 6, I've already got a 7 and a 4. I've already got a 7 and a 5. I've already got a 7 and a 6. So these 6 right here would be the answer. I want those things taken 2 at a time, okay? Now, I hate those questions. Everything after that, I think, is much better questions. So 4, 5, 6, 7, these are calculator questions, so get your calculators out and get ready to go. You're going to need the permutation button. It might say P, it might say NPR, it might be hidden inside of a math menu for those of you that have a TI. But look for the button that says P. So on my calculator, it's way over there on the right, and you're going to have to hit the second button to get it. But I want 9P4. What that means is out of a group of 9 items, we're going to take 4 items and put them in order. So 9P4 is 3024. And they're saying how many ways are there of taking 4 out of 9 and putting them in order? So, yep. If I had 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 people in this room. If I took 4 of you and lined you up at the door, if I said I want 4 people to line up at the door, all right, there'd be that many ways, 3024 different ways of me doing you, then you, or you, then you. It is crazy. All right, 5P5 means take all 5 out of 5 and put them in order. That's 120. 120. Make sure you know how to use that button on your calculator. If you can't use that button on your calculator, you're going to have to do a lot more math. Now, incidentally, if I'm taking all 5 of the items and putting them in order, that's the same thing as a factorial. But it's more obvious that it's a permutation here. Now, 14C5, NCR, that's taking 5 items out of 14, and I don't care what the order is. So I'm just picking 5 people. Who cares who's first? Don't care. So order doesn't matter with a C. That's 2002. 16C11, 16C11. Take 11 out of 16. I don't care what the order is. 4368. Pretty quick questions if you have a calculator. Find the number of unique permutations of the letters in each word. Permutations means order matters. But I see 1, 2, 3, 4, 5. And so what you could do is 5P5 if you want. Well, we just did that a second ago, didn't we? That was 120. But it's also the same thing as 5 factorial. So this one, lizard, 1, 2, 3, 4, 5, 6. This is going to be 6P6 or 6 factorial, either way you want to do it. We're taking all 6 letters and putting them in order. That's 720. 720. Now the main event. Okay. These problems are the important ones. Make sure you're paying attention. So find the number of possibilities at each scenario. We're counting. How many ways are there of doing such and such a thing? Number 10 says a group of 45 people are going to run a race. The top 3 runners can earn gold, silver, and bronze medals. So the main focus of the problem is it's pretty easy to tell that we're going to take 3 people out of 45 people. But your question has to be, does order matter here or not? All right, does order matter or not? So if you're running in a race, do you care whether you get gold, silver, or bronze? Absolutely. Order matters. I want to be first. Okay, I'd rather be first than second. So order matters. That's how I know this is a P, not a C. 45 P3. 85,140. Okay. 11, you're setting the combination on a 4-digit lock. You want to use the numbers 3, 8, 1, 7, but don't care what order they're in. Okay. So don't care what order they're in. So I know I want those 4 numbers. That's, I don't know. I'm using those 4. I feel like this is a trick question. I don't like that it says there you don't care what order they're in, because you got 4 numbers and you want to use all 4 of those numbers, and if you didn't care what order they're in, that's 1, but that can't be right. I don't think that's true. Okay, I look at this as a blanks problem. Setting the combination, you want to use those numbers. How many ways of picking the first number? Well, it's either 3, 8, 1, or 7. And then after you pick that, there'd be 3 choices. That to me looks like a permutation. That looks like a factorial. That's 4 factorial. And 4 factorial or 4P4. Notice I just said 4C4 was 1. That's one that comes up a lot. If you've got number choose itself, number C itself, it's always going to be 1, but number P itself is always going to be a factorial. So I think I don't like that question at all. I think that's tricky because when it says don't care what order it is, that usually means it's a combination. Yeah, really think about that one. The batting order for 10 players on a 12-person team, okay? So we're picking 10 out of the 12 and putting them in order, the batting order, okay? The first hitter is important. The fourth hitter is important, all right? The order matters. Ooh, that's a big number. 2395. 239500800. That's a lot of ways. I mean, there's a lot. If you think about it, you can do this one as a blanks problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 places in that order. How many ways of choosing the first batter? Well, I've got 12. And then after that, I've got 11 and 10 and 9 and 8 and 7, 6, 5, 4, 3. If you multiply all those numbers together, that's 239,500,800. All right, it's a lot. 13, there are 30 applicants for 3 jobs: computer programmer, software tester, and manager. So it's pretty easy, I think, to see it's a group. It's a group from a group. But the question is, does order matter or not? If they're different jobs and you can tell, I like to use the example of computer programmer, software tester, and janitor. Okay, so you're probably going to notice a difference between those jobs. Order matters in which they're picked, so that's a permutation. Okay, president, manager, dishwasher. All right, you're definitely going to notice a difference between those jobs. I think order matters. 24,360. Incidentally, a permutation happens to be part of a factorial. In this case, it's the first 3 parts of the factorial. 30 times 29 times 28. I thought this was interesting when I learned that. All right. 30 times 29 times 28 is the first 3 pieces of a factorial. And that's what we just found. Team of 12 lacrosse players needs to choose 3 players to refill the water cooler. All right, so it's a group out of a group. I know I want 3 out of 12, but does the order in which they're picked matter? Does it matter who I picked first? I picked 3 people to go fill the water cooler. Who cares who's first? Order does not matter here. That's a combination. That is a combination. 12, choose 3. 220. How many ways to do that? Number 15, there are 15 applicants for 4 systems engineer positions. So again, it's a group from a group. I want 4 out of 15, okay? There are 4 systems engineer positions. It's the same job. Do I care which one I get? They're all the same. Order doesn't matter here. That's a C. 15C4, 1365. Number 16. Group of 25 people are going to run a race. The top 12 finishers advance to the finals. So again, group from a group. I want 12 out of 25. Top 12 finishers advance. That's like me saying, like, okay, you got, of you, I'm going to take 4 people and, buy you lunch, all right? If I'm going to take 4 people and buy you lunch, do you care who goes first? Doesn't really matter, right? I get it. All 4 are going to get it. Top 12 finishers advance. Doesn't matter if you're first or 12th. Order doesn't matter. All right. 12 or 25C12. Five 2 0 0 3 0 0. 4 out of 9 students will ride in a car instead of a van. Does order matter? Order does not matter. 9C4. 126.